So back in Algebra 2 and Pre-Cal, you learned how to, you really already knew the rules for rational functions, and so when we're doing them in this class, we're just treating them differently as limits. But the type of function that we're going to talk about now is a type of function that you wouldn't have been able to do in Algebra 2 or Pre-Cal because we didn't have that limit understanding yet. So here we have a function that's not rational. We have 3x minus 2 over the square root of the quantity 2x squared plus 1. And when we look at the horizontal asymptotes of this type of a function, we need to consider both the limit as x approaches positive infinity and the limit as x approaches negative infinity. And we'll see why that's the case in a second here, hopefully. But we'll talk about the limit as x approaches positive infinity first. And so one of the important concepts here is that for positive x values, x is equal to the square root of x squared. All right, so if I had, let's say I had x equals 2, then I know that 2 is equal to the square root of 2 squared. Right? So this is the relationship that we're going to use for our positive values, for our positive x values. All right, so we have the same idea as what we used in the rational functions. So I have x, and here you can see that I have an x squared inside the square root. So it's effectively a power of 1 still. So I have an x in the numerator and the equivalent of an x in the denominator. All right. So we're going to divide both numerator and denominator by x. So in the numerator, I'm going to just divide by x, and in the denominator, I'm going to divide by the square root of x squared. All right. Once again, I'm using this relationship here, x equals the square root of x squared. So the numerator I'm going to divide by x, the denominator I'm going to divide by the square root of x squared. Since I'm dividing by the square root of x squared, this x squared can move inside the radical with the 2x squared plus 1, and then I'm going to reduce everything there. So here I get 3 minus 2 over x. Here I get 2 plus 1 over x squared, and that's all inside the radical. Now I can use substitution and evaluate each of these limits using substitution. So I substitute infinity in for x. I get a 2 over infinity, which approaches 0. I use x here, and I use infinity here with the x squared. I get a 1 over infinity squared, which approaches 0. And so the final limit that I get is 3 over root 2. All right. So that gives me the limit as x approaches positive infinity. Now let's look at what happens when x approaches negative infinity. So the key for this part is that for negative x values, we have a different relationship. We have x equals the opposite of the square root of x squared. And you can see that if we choose like a negative 2 for our x value, x equals negative 2, and that is going to equal, if I just have the square root of x squared, this is going to give me 2. But I need it to equal the original x value, so it needs a negative sign in front of it. So now instead of dividing numerator and denominator by x and the square root of x like I did here, I'm going to divide numerator and denominator by x and the opposite of the square root of x squared. So I'm really dividing by the same thing, given the knowledge that my x values are negative. All right, and from there I follow the same route. I bring this x squared inside the radical with the 2x squared plus 1. I reduce it, but you can see that I still have this negative sign here. And so when I solve that limit by substitution, I substitute negative infinity in both places. I get 2 over negative infinity approaches 0. I get 1 over negative infinity squared approaches 0. And now I have negative 3 over root 2. So my horizontal asymptote in the negative infinity direction is negative root 3 over 2, whereas my horizontal asymptote in the positive infinity direction was positive 3 over 2. So that would look this graph, if we graphed it on the calculator, we would see that it would look this way. So the important thing to note here, we're really only talking about, in this section, we're talking about these parts, right? The end behavior. So very far off to the right and very far off to the left. This middle behavior, we could get some information about this using earlier chapter 3 stuff. We could use concavity and relative mins and maxes to find some of this information. But for the time being, just look at these horizontal asymptotes in the positive direction and the negative direction. So notice that it has 2 horizontal asymptotes and that we can cross a horizontal asymptote. Right? In this case, we do cross this lower asymptote down here. And that's something that you don't generally see in Algebra 2 and Pre-Cal, because if we cross the horizontal asymptote, it makes it difficult to know what's going on here without the use of concavity and relative maxes and mins. So that's why you kind of generally try to avoid those types of functions in Algebra 2 and Pre-Cal.